My name is Emily. I'm from the blue team. My teammates are Jacqueline, JJ, and Rachel. And today I'm going to talk to you guys about the voltage systems proportional controller. First, I'm going to talk to you about our background and some of the past experiments that we've done. Then I'm going to get into this week's topic. I'm going to show you our results, and then we will conclude. This is our system, a picture of our system. And this is the block diagram for our system, which you all have seen 4 or 5 times now. Our schematic. This is a trial of our SSOC, putting it together. And this is our completed SSOC. It's unique because you can see in the circled region, if you take the data in increasing intervals, it's different from when you take it in decreasing. So there's a lot of difference between this is decreasing and this is increasing. That's one thing that's unique about our system, which there are several things that are unique about our system. You'll see. Another SSOC, region 3. I mean, this is just showing that our SSOC is not linear. It's completely different from most systems. Unique qualities, voltage output. As I stated before, decreasing intervals are different than increasing intervals. They produce a different SSOC, and it's not linear. Do you want me to go over? You do?
All right, bing.
Oh, okay. This is one thing that I will talk about is, I mean, I'll talk
whether
about
you
all
ding
of
or
it,
not.
it's different from what we've seen before. So, as you can tell, or maybe you can or cannot, I'm showing you, that this step-up graph, in most cases, it has a nice curve. You know, the slope decreases as the time goes on. But in our case, we kind of have a dip here. That's one thing that is different. That was just for one case, though. It's not always like that. In this situation, it does have a nice, steady, decreasing slope. Here's another unique quality about our system. In the purple triangles that you see, we tried to get it to line up the best that we could with the model. And in most cases, they do. It kind of has a steadily dropping slope. But in our case, it kind of it drops and then it gets steady and then it drops again. So that is a very unique quality. This is how we measure our root locus. It's just an example of where you find ultimate, quarter, and critical, and then C10, C110, and C500. And this is our KC values that we found from doing our root locus. You saw these also during our last presentation, if you look here. The values for the range of 0 to 15 were huge. They were really large. They didn't really make a lot of sense to us, but I'll explain that more when we get further on into it. This is a comparison of the highest and lowest values of KCs. And 0 to 15 range always had the highest value. This is ultimate frequencies for the different ranges. 0 to 15 and 45 to 60 were relay, the rest were Bodie. Once again, this is another comparison from the different ranges. 186 was the highest KCU. and not the volt ranges on the x-axis as before. This is our final results. The table is a little bit difficult to read, but you can clearly tell that KC for the 0 to 15 range is always higher. It doesn't really go like the ones in the other ranges. Root locus conclusions, the upper, mid, and lower ranges do not share the same behavior. And root ranges 0 to 45 had less variance than the upper regions. Comparing root locus and response KCU, 0 to 30 range had a significantly more deviation than 30 to 75. And this is this week's focus. This is the 0 to 15 ranges in bar verification, and it is accurate because the output, which is the red line or the red squares, matches up with the set point. And M-bar is 50 and set point is 2.2. And this is a lot, well, very different from most systems. It doesn't really sound like 2.2 volts would be a M-bar of 50, but going back to our SSOC, you can see that, or I'm going to show you, that 50% is here, and that is about 2. This is our experimental critical KC, and the output is shown in red squares again. There is a step up from 2.2 to 12.2, so 10, and we have an offset of about 8, and it's monotonic. This is our quarter, and instead of, in most cases, the steady state line that you would measure your oscillations at is straight across, just completely vertical or horizontal. Sorry. And in our case, it's different. So I measured it from using this diagonal line and this first oscillation and the second oscillation. This is a very unique quality of our system. Most systems oscillate and then they go into steady state. And in our system, our oscillation increases as time goes on. No other system does this. This is a comparison of root locus to proportional control values. And I used this is just from the 0 to 15 voltage range because it has the biggest difference. As I stated before, when we did root locus, I got a KCU of about 168. I used 190 so that the significant digits would work out. But when we did it with proportional control, it was a lot of difference, and I ended up with a much smaller value. This is a comparison of all ranges, and it did not, the values we found for root locus were not verified in any case except for KCCD in the 30 to 45 voltage range and 60 to 75 voltage range. Everywhere else, it varied significantly. Instead of the chart that I showed you in the previous slide, this is just a graphical depiction so that you can see it better. As it shows, 30 to 45 is close, and then 60 to 75 is close. These are a comparison of KCCD for root locus and proportional. This is a comparison of KCU values in which none of them were really validated. And this is a comparison of quarter, and they were not validated either. These are the characteristics of our graphs, and they were all monotonic. We didn't have much of an overshoot because they stayed much lower. We did have quite a bit of offset in most cases. settling time because our graph never settled. It kept oscillating. It never was a straight line like most systems. And it was very oscillatory. In conclusion, the values found using root locus were not validated in most areas. In fact, they were very different. KCCD values found by using root locus were validated in ranges 30 to 45, and lowest voltage range still has the largest KC values. It's not as large as 190 or 186, but it's still larger than every other range. And values found using root locus may need to be recalculated because the numbers were quite ridiculous. Any questions?